Drawing vectors. A vector is a directed line segment that has two things. It has magnitude and it has direction. The magnitude is the length, and it can also be thought of as the radius if you're in polar coordinates. And the direction is the angle measure, thought of as the angle of the polar coordinates, the second coordinate. Now, we will use vectors to help us understand word problems. So how we're going to do that is we're going to have our initial starting point, which will generally be at the origin. And then we draw an arrow towards our terminal ending point. And we find that point by drawing our angle measure from our zero axis around to whatever angle is being measured. All right, now we're going to draw a few vectors. We want to draw the vector to indicate the problem and then calculate the terminal point. Every Sunday, Sandy goes for a morning walk in the direction of west of south at 55 degrees. She walks at least 3 kilometers. So if I'm looking at this, south would be going down, so west of south would be going that direction there. And she goes 3 kilometers. So that's my radius. And then I know that this angle right here is 55 degrees. Okay, so what we want to do is we want to think about what we have here. Because generally, when we are finding our xy coordinates, we know that x equals r times the cosine of theta, and y equals r times the sine of theta. However, this is when we are measuring from the x-axis. However, on this one, our angle is being measured from our y-axis. So we have to switch our x and our y around. So x is going to equal r times the sine of theta, and y is going to equal r times the cosine of theta. So if we're measuring from the y, then we need to switch our x and our y. If we're measuring from the x like normal, then it's x with the cosine and y with the sine. Okay, so now it's a pretty straightforward problem. X equals my r, which is actually a negative because we're going negative on my x-axis, negative 3 times the sine of 55 degrees, which is approximately equal to negative 2.451. And my y is equal to negative 3 times the cosine of 55 degrees, which is approximately equal to negative 1.719, somewhere in there. So what that means is my xy coordinate would be negative 2.451, negative 1.719. And that's your final answer. We needed to draw that picture so we understand which direction we're going. All right, and the next one, Kelly moves her boat 20 kilometers to the west of south at 40 degrees. Okay, so west of south, so here's south and here's west. So west of south would be here, and it's 20 kilometers. So that's my radius, and west of south would be 40 degrees. All right, so again, we're going to be measuring from the y-axis. So that means we're going to switch our x and our y in relation to our sine and our cosine. So we're going to have x equals negative r, again, because we're going towards the negative, times the sine of theta, and my y is going to equal negative r times the cosine of theta, because my y is also going negative. Okay, and then again, pretty straightforward problem. X equals negative 20 times the sine of 40, which means that x is going to be approximately equal to negative 12.86, depending on how you round. And y is going to be equal to negative 20 times the cosine of my theta, which is 40 degrees. So my y will be approximately equal to negative 15.32, depending on how you round, meaning that our terminal point is going to be negative 12.86 and negative 15.32. In this next one, Daniel went to his nephew's birthday party. His house is 60 degrees east of south and 600 meters from his nephew's house. So his house, we'll consider at the origin, 60 degrees east of south is going to be right there. So we have 60 degrees and it's 600 meters. Now this one's a little bit different from the last one. We are still measuring from the y-axis. So we still have to switch our x and our y in a sense of our sine and cosine. So that means we're still going to have our x with our sine of theta, and our y is still going to be with our cosine of theta. Now we have to look to see which ones are negative. Okay, so my x is going to go towards the positive, my y is still going down towards the negative. So that means my x is going to be a positive radius, and my y is going to be a negative radius. Okay, so then if I put in what I know, x equals positive, my radius is 600, so 600 times the sine of 60 degrees. And then x is going to be approximately equal to 600 times the sine of 60, which is about 519.62, somewhere in there. And my y, this one is negative, so I have negative 600 times the cosine of 60. So y is going to be approximately equal to negative 600 times the cosine of 60 degrees. If you type that into the calculator, you get negative 300. So what that means is the point 519.62 negative 300 is his nephew's house. And this last example, Robert walks 1,200 meters at 90 degrees west of south. So 90 degrees west of south is going to be up here. And he's going to walk 1,200 meters. Well, we can look at this a different way, and then we can go on our x-axis. This right here is a straight angle, so that means that would be 180 degrees this way. So we look at it as a measure from the x-axis this time. So what we would do is we would have our x equal to our radius times the cosine of theta, because we're going to call our 180 degrees theta. And our y is going to be equal to my r times the sine of theta. All right, so now for solving for x, do our substitution. X equals 1,200, because that is the radius of my angle here, times the cosine of 180. Cosine of 180 degrees is actually negative 1, so I have x times equals 1,200 times negative 1, or negative 1,200, which we can actually see that just by looking at our picture. If it goes 1,200 degrees this, or 1,200 meters this way, and that is negative, so that's why it's negative 1,200. And then if we look at our y equals 1,200 times the sine of 180 degrees. Sine of 180 is 0, so we have 1,200 times 0, which is 0. So the point, negative 1,200, 0, is where Robert is going to be walking to. And those are your notes over drawing vectors. Go through some practice problems. Make sure you understand the different ways that vectors can be drawn, and then prepare for your quiz over the material.